Good morning, students. Till yesterday, we have learned about the representation of data in a tabular form. Now, today we will learn about another representation of data, that is the graphical representation. In this class, we will be understanding about the following types of graphical representation, that is bar graphs, histograms of uniform width, and frequency polygon. Now, bar graph. This type of graph you have learnt in class 8 also. So, just recall what is a bar graph. It is a pictorial representation of data in which usually bars of uniform width are drawn with equal spacing between them. Remember, equal spacing between them on x-axis, depicting the variables in the y-axis, and the heights of the bars depends on the values of the variable. Let us see this example. It is given that in a particular section of class 9, 40 students were asked about the month of their birth, and the following graph was prepared for the data so obtained. So just see this figure 14.1. So it is the figure which is given about 40 students and their months of births are given. Then the question is asked on the basis of this graph. So the first question is, how many students were born in the month of November? So when you will see the graph, just find out, you will see that in the month of November, 4 students were born. Next question is, in which month were the maximum number of students born? In this case, you observe the graph, you will find that the longest bar is in the month of August. So in the month of August, maximum number of students were born. Now suppose that we have to show frequency distribution table for continuous class intervals graphically. In that case, we will not use bar graph. In the case of continuous class intervals, we will use another type of graph, that is histogram. So what is a histogram? This is a form of representation like the bar graph, but it is used for continuous class intervals. So histogram is also like a bar graph, but it is used for continuous class intervals. So just see this example. Here frequency distribution table is given for the weights of 36 students of a class. Let us find out how it is represented in the form of histogram. Now this is the histogram. Let us see how is it made. The weights are represented on the horizontal axis, that is x-axis, and the number of students, that is the frequency, is taken on the y-axis. Now what do you find when you see the class interval? You will find out that it has started from 30.5 to 35.5. Since the first class interval is starting from 30.5 and not 0, so we will show it on a graph by a kink, this, or a break on the x-axis. Now we will draw the rectangles or rectangular bars of equal width. It should be of equal width, remember, of equal width, equal to the class size and lengths according to the frequencies of the corresponding class intervals. Like in between 30.5 to 35.5, the number of students were 9. Then between 35.5 to 40.5, number of students were 6, and so on, 15, 3, 1 and 2. So what do you find? This is a histogram. Now what do you find here? That it is a graphical representation of a grouped frequency distribution with continuous classes. So what is the difference between bar graph and histogram? Over there was equal spacing between the two rectangles, while here you will find out that they are in continuity. They are continuous in nature. So this is the difference between bar graph and histogram. Now the third type of graphical representation is frequency polygon. There is yet another visual way of representative quantitative data and its frequencies. This is a polygon. For this, let us go back to the previous example which we had done just now to draw the histogram. In that case, just see that histogram once again, that is figure 14.3. So we have taken that histogram once again, and let us join the midpoints of the upper sides of the adjacent rectangles of this histogram by means of line segments. Whatever histogram we made, whatever rectangles we made in the previous question, just take the midpoints of those rectangles, okay, and then join them with the help of the line segment. Now let us call these midpoints as B, C, D, E, F and G. Then we join this line and these figures or these points with the help of line segments, and we obtain a figure B, C, D, E, F and G. To complete the polygon, we assume that there is a class interval with frequency 0, and before 30.5 we will take the equal intervals. Before 30.5 we will take 25.5. Similarly, after 60.5 there is an interval of 5, isn't it? After each, you will find out that after 30.5 it is 35. So there is a gap of class width of 5. So again after 60.5 we will take 65.5, and we will name their midpoints as A and H. So A, B, C, D, E, F, G, H is the frequency polygon corresponding to the data of the figure 14.3. So students, these are the three types of graphical representations. Questions we will do, exercise we will do in the next class. For that you need a graph copy. Thank you.